Hello and welcome back to another mathematics tutorial. Today I'm going to be showing you the triangle inequality for real numbers. This is extremely useful, particularly in university mathematics. You'll see it used time and time again. Now we have the statement over here on the left hand side. So it says if we have two real numbers, a and b, then it tells us that the modulus of a plus b is less than or equal to the modulus of a plus the modulus of b. Now, how do we prove this statement? Well, the proof is quite straightforward in this particular situation, and it's useful to look at the proof because it will give you an idea of one of the techniques of proof you can use in university mathematics or just in mathematics in general. So the method we will use is something called case analysis. So this is where we have a small number of possibilities or cases to consider, and we just look at each one individually and try to deduce the same thing in each situation. So let's have a look at what case 1 could be. Well, case 1 is going to be a is greater than or equal to 0, and b is also greater than or equal to 0. So then what? Well, what does the modulus of a plus b look like? Well, it's just a plus b, because since they're both greater than or equal to 0, a plus b is going to be greater than or equal to 0, so the modulus just gives us a plus b back out. And then this is equal to the modulus of a plus the modulus of b. And we're done, because we have this statement because a is greater than or equal to 0, so a is the modulus of a, and then the same for b as well. And we've shown equality here, and we wanted to show less than or equal to, but equality is still within that less than or equal to condition, so we're good. Case 1 is done. Now, what about case number 2? What would case number 2 look like? Well, let's have a greater than or equal to 0, but b is less than 0, so b is negative this time. Then what does the modulus of a plus the modulus of b look like? Well, that's just a minus b. Okay, what can we do with this? Well, this is certainly greater than or equal to a plus b, because b is negative. So we're taking away a negative number, a minus b, so we're essentially going to be making it bigger. You know, if we were doing a minus 1, that would be a plus 1, so we've made it bigger than just doing a minus 1. So that's fairly easy to see. And also, it's greater than or equal to minus a minus b, because a is non-negative, so a is greater than or equal to minus a. So I will write this down. So as b is less than 0 and a is greater than or equal to minus a. So a being non-negative, the minus of a is going to be less than or equal to 0. So this is fairly easy to see. And then the modulus of a plus b is either a plus b or minus a plus b. And don't forget that minus a plus b is just minus a minus b. So we're done here again, because we've shown that this modulus of a plus the modulus of b is greater than or equal to the modulus of a plus b in any case. So we're done. Case number 2 is finished. What about case number 3? Well, case number 3, what about a is less than 0 and b is less than 0? Well, this is similar to the first case, so I will leave this to you to try by yourself. Just follow the same principles that I've used here in the other 2 cases, and you should be able to get it fairly easily. If you can't, then just leave a comment in the comment section, and I will try my best to answer your question or your confusion. Now, make sure you memorize the statement of the triangle inequality. It's very useful, and you should always try and use it if you can. It will often help your problem. Not always, but and a lot of times it will be quite useful. Right, thank you for watching, and don't forget to leave a like and subscribe to my channel for more mathematics videos.